I'm Nikolai Vlasov. I'm Senior Solutions Architect with Amazon Web Services, and specifically the Advanced Compute team, and I'm focused on helping our customers to run blockchain nodes on AWS. And today I would like to share with you some of the things that I've been building with the help of Solana Foundation, and share more about AWS itself. So let's start with a little bit of a history. In August 2006, our chief evangelist, Jeff Barr, has announced a new service that was called Amazon Elastic Compute Cloud. So 2006, it's like 2 years before the Bitcoin paper, right? Now, it was really small instance. It was like 1.6 gigahertz processor with less than 2 gigabytes of RAM and a small disk and not really fast network. But fast forward into today, and what we see is over 30 billion instances launched since then. That really speaks of the scale. And if we translate it to daily, it's like 100 million instances per day. Without innovation that is backing this up, it would be hard to build to that type of scale. And that's what we do, actually. We provide customers with tools and services to securely and reliably run virtually any workload. Now, I would like to share with you the way to run Solana nodes on AWS, which is available now. It's self-service infrastructure as code application that is available open source on the AWS Blockchain Node Runner's GitHub repository. And you can clone it, and with a couple of commands, you can spin up a Solana node. So I'm really happy to see now the Solana nodes are available for US developers to get them closer to your cloud-native web applications that you build on AWS. Now, you can run a solo configuration or solo deployment with a single node. And with a solo deployment, it's really for you to test things out, to see how the nodes work, how they perform. They'll probably do some performance testing. The infrastructure as code application will provision things like the CloudWatch dashboard for you to see the monitoring details of the node itself, the EC2 instance that is underpinning the node, and the KPIs from the Solana validator process, like the block head and the slots behind. Now, the other option for you is the high availability nodes. And this works for RPC nodes. And with high availability, you can basically spin up, again with this couple of commands, spin up multiple Solana nodes behind the load balancer that is exposed internally for your applications to use. So from the traffic perspective, those nodes still sync with the rest of the network, but the APIs are available locally to your applications, so you can save on the outbound traffic. And the auto-scaling group behind the scenes keeps track of the number of nodes running. And if there's something happens with one of them, it gets replaced by a new one automatically. And you can extend these applications because they are open source to introduce new scenarios to react on different other metrics that the nodes are reporting back to the CloudWatch service. Based on them, you can script up other behaviors to scale in, let's say, the situation where you need bigger demand, for example, or experience bigger demand for your service, and then scale back down when the demand is over. Now, there are 3 configurations that are available for you to provision. Now, all 3 are available in solo mode, but only last 2 are available in the high availability node. The consensus configuration is for validators to try out running the validator nodes, but for you as developers, you're probably more interested in the next 2, which are the base RPC node and the extended RPC node. The base RPC nodes are those that do not have the secondary indexes enabled, and the extended RPC nodes are those with secondary indexes. So you can experience full richness of the API, the RPC API. Now, from the infrastructure perspective, the default configurations are on x86 machines, both AMD for the first 2 and Intel-based for the last one. But this is configurable. So the configuration itself is available to you. You can change the instance types and storage types. And we separate the accounts volume from data volume for better performance. And you can change and switch the block storage depending on what you actually need. Now, there is also an experimental option which is currently not automated, but there is a way to use it. And it is based on the ARM-powered Graviton3 instance types that are available on AWS. Graviton processors are built for cloud-native applications, and they consume less power and they're more environmentally friendly, and they're more cost-effective usually than x86 machines. This works for the first 2 configuration options, and I say they're experimental because we all know that Solana isn't yet fully support the ARM machines. But I tested them and they work. Now, the other statistics I decided to show you is the data transfer, so that you will be aware that the data transfer can be quite significant when you run those nodes, especially for consensus node at the very top. But for the RPC nodes, since we're exposing the APIs internally only, the traffic is going down to about 15 terabytes per month. Now, we also know that Solana validators run very well on AMD processors. And in September this year, we announced the 4th generation of AMD EPYC processors available on the Amazon instance, EC2 instance types R7A. They are 3.7 gigahertz machines, and they are about 50% faster than the previous generation that is running on AWS. Now, I would also like to talk about cost optimization, because this is a topic that we hear from our customers quite a lot nowadays. And the cost optimization, as we define it in AWS, it's not only about spending less, it's also about spending smarter. And there are many ways to achieve this. I just picked these 3 because I think they are the most relevant when it comes to running Solana nodes. The first is really about choosing the right purchase models. With you committing to, let's say, 1 or 3 years, you can get a deeper discount on the computer instances. The other one is to match capacity with demand, because what we see, some of our customers, they are over-provisioning to match the demand that is not really happening at the moment. With services like AWS Compute Optimizer, which is powered by an ML model, and it is constantly monitoring your workloads, such as storage and compute, it can provide you recommendations on which other compute options are available for you to meet the same demand, or how to switch to another, or can recommend you to switch to another storage option or tweak the configuration in a certain way. The auto-scaling, which I mentioned before, is already implemented in the high availability configuration. Helps you to elastically change the number of nodes supporting the demand as it changes as well. And with AWS Cost Explorer, you can easily implement the right sizing configurations, recommendations into your workloads. And last but not least is probably the most important one. It's about talking to your AWS account team. Because unlike maybe you experienced with other vendors, we at AWS are really taking cost optimization seriously. Frugality is one of our core leadership principles, and AWS was reducing the prices throughout its history. So your account team is there to help you to optimize the costs. But it's not only the account team, it's also our partners who bulk purchase services from AWS and can resell it to you with a discount. Now, when it comes to building applications on AWS, there are over 200 services to choose from. And I picked the ones that I think are the most relevant to Web3 kind of applications. And it's not that I think about it, it's also the customers who I speak to, they usually use these services. The important thing about them is that, for example, for core services, there is an innovation behind it that helps you to achieve better results that you can probably experience in other places. If we take EC2, for example, EC2 is, as you know, has a hypervisor behind it. But this hypervisor is designed in a way that it reduces the workload on the central processor by offloading the networking and storage and security operations to hardware and software outside of the actual instance. That way you can get up to 50% more than you experience on other, 50% more speed, processor speed, than you experience on other cloud providers. It's really virtually a bare metal kind of speed that you are getting from it. Now, the other important services to mention are the security. We see Web3 applications are using the AWS Cloud Key Management Service to secure the keys and use them in a safe way. Same goes with the Cloud HSM, but those are more for the regulated customers who really need to have the HSM module managing their keys. And the AWS Nitro Enclaves, which are secure execution environments that run alongside the EC2 instances and allow you to implement those safe and secure computations with protected RAM and protected whole execution environment. That way you can implement your own custom encryption that are not supported by the existing services of AWS, or you can implement your own data processing that is supposed to be private. Next are API and networking services. For API, we have the API management services like the Amazon API Gateway for REST APIs and AWS AppSync for GraphQL APIs. But then for networking, and network cost optimization is a very important topic for Solana nodes. There are two more services that can help you with that. First is Private Link, that allows you to connect multiple AWS accounts, even those that belong to other organizations, with your environment through the AWS networks. So with Private Link, you don't need to expose, let's say, the REST APIs or RPC APIs to the outside for others to consume. You can directly link them to your customers and have better latency and lower costs. With AWS Direct Connect, you can do a similar thing, but with bare metal providers or with on-premises data centers. Now, something that I've learned building the Web3 applications myself is that blockchain is usually not enough you need other services to support you to provide better user experience. And storage systems are probably the next most important ones when it comes to actually building the application, next important after compute. With storage systems like purpose-built databases, ranging from key-value stores to graph databases, you can actually address multiple use cases that you might need to implement in your app. And storage systems are there to store your off-chain content in order to serve it as part of your user experience. And if you're just starting your journey, the rapid application development tools are there also to help you. The service like the AWS Amplify allows you to build the web and mobile applications automatically backed by the cloud-based services. So you can focus on building the application itself, and the libraries and the command line tools will automatically provision the backend applications for you, and the libraries will integrate those services in a secure way with your applications. Speaking of startups and starting up with AWS, we have programs that help startups to build on AWS, and we work with startups a lot. And I'm happy to share with you that the AWS Activate program is now available through Solana Ventures. So if you are a startup and you join the Solana Ventures, there are up to $25,000 available for you to spend on AWS services throughout 2 years. That's really to get you started. When you start scaling, AWS can help you with access to expertise like myself and others that are specialized in other aspects of the applications that you build, be it databases, networking, security, etc. When you scale further and you need to reach out to more customers and partners, our go-to-market teams, or GTM teams as we call it, are there to help you to spread the word. We're on conferences, we're on meetups. We publish the case studies together with our customers and partners to show and tell the story of the AWS used in different kinds of applications. And I would like to conclude with this. This morning, Anatoly was telling a story of Solana as a global state machine. Thank you so much. Yes, as a global state machine. And state machine is there for you on Solana to replicate the most important information for your application, which is transactional data. Now, being a global means that your users are also global. You need to potentially reach out to users in other parts of the world, depending on where demand is going from. And at AWS, we have currently 32 regions, which are distinct geographic locations, each of which is backed by at least 3 availability zones, which are distinct data centers, to deploy highly available applications even within a single region. Now, with automated deployments, you can scale your user experience to these 32 locations already available to you and 4 more regions that are coming soon. So with that, I just want to thank you, and let's keep building.